Okay, gents, so getting into the last part of our course this afternoon. So, tyre management. Now, see, this is one of the most important things that we can cover as race engineers. So, our tyres control all the forces. So, any downforce, braking, acceleration, lateral force, hopefully, tyres are the only part of the car that contact the ground. So all our energies that we try to control all go through the tyre. So you've got your vertical load goes down through it, acceleration loads, braking, lateral forces. And they're the only point that's in contact with the ground. So that's why tyres, for me, are really, really important. They're critical for the performance of the vehicle. Look at Formula One, how much energy they spend on tyres. So, we need to spend a lot of time in understanding why that is. When we sort of look at, the relative improvement in lap times from vehicles, over history, and the two big major improvements has been tyre development and aero. Both of those have gone hand in hand. How long tyres last, durability. Le Mans doing multiple stints on tyres at the same pace. It's quite impressive where tyre technology's gone. So one of the important things to do with tyre management is tyre labelling. I'm going to cover that off. So supercars is a pretty good example of this. They sort of get roughly 6 sets of tyres per event. So it's a fair number of size, plus the tyres they bring. They might have 6 test-only sets for the year. They have 2 different compounds they have to manage, plus wets. So they roughly get around 400 tyres per year, maybe more, maybe less, depends what the rules are. They shuffle that up every time and change it all, just to make it difficult for everyone. And you might carry over tyres from year to year. You might carry tyres over 2 seasons. If you're really unfortunate, we're using tyres which are 2 years old for your practice set, because that's what you've got in your bank. So you've got to be, monitoring all these. And you need to be able to account for every single tyre in your bank, where it is. You've got a maximum amount of stock you can carry, so you need to work out which ones you want to keep, which ones you can't keep. And so that juggling act is quite complicated. So obviously not every category's got that requirement, but you might not have enough space in your workshop. You might not be able to afford that many wheels. You've got to keep track of what you've got and what you're going to use where, to get the optimum performance when you do go testing. So in this section, we want to cover off the importance of labelling tyres. Touched on that a little bit with the V8 sort of thing there. We're going to try and plan our tyre usage. How would you use tyres? What's the best way of going about it? We'll go through a few examples. How to measure tyres, and what sort of records we need to keep on tyres. So these are all the important aspects we need to cover off in understanding the concept of tyre management. So tyre labelling. So as we discussed earlier, most tyres have a serial number or barcode on them. That identifies each unique tyre. I generally label the tyres as a year and then a set number, so that way I know when it's the next year. Other categories, they may do it slightly differently. That's generally my rule of thumb. You'll find something that works for you. You may only have 3 sets a year because that's what racing you do, so maybe it's important to label them slightly differently. I try to label them in event sets as well. So you can call the tyres you want to your crew. So I want set 1, set 2, set 3, set A, B, C. Some form of way of doing that. So I normally call them practice 1, practice 2, practice 3 set, so on, so forth, and race 1, race 2, race 3. And obviously, in a lot of categories, you can't use your practice tyres as in the racing. They're for practice only. So the P and the R designates, hang on a minute, this is the wrong tyre on the car. You can then also label them in numbers. So it would be the first set of tyres, so race 1 set would be the left front, right front, 1, 2, 3, 4. We'll show an example of that in a sec. So this is a rough sort of tyre allocation for an event, I'd say. So we've got our serial numbers here. That was from set 15100, so it was a high numbers set from the previous year. And for the event, that's my practice 1 sets. You can see here, practice 2 set, practice 3 set. Fortunately, I've put them all in sets where they are originally used, but sometimes you might grab the fronts from 2 sets, put them together, just keeping on top of them. And that's where there's no point calling for set 1501 when it's a 1501 tyre, a 2 tyre and a 100 tyre in one set, because sometimes you'll have to juggle that up. And they're all reasonably straightforward. Same with the race sets. We've got serial numbers, different serial numbers for the race sets. They're obviously this year's sets. I've labelled them up for race sets, and I've also given them an event number, so 1, 2, 3, 4, 5, 6, 7, 8. So that's normally my numbering system. I think that's basically what the French sort of system based on, is most people around the world will number tyres that way. Is that your experience? Yeah.
Yeah. Yep.
Yeah. Some teams will do it clockwise around the car or anti-clockwise around the car and all sorts of things like that. That's 90% of people I've come across use that system. I use that because if I don't, I mess it up. That's why my brain's programmed. I've done it for so long. That's what I get used to. So that's a general sort of, okay, that's my IDs and serials. So these numbers will stay on the set permanently. So, it'll have that serial number. You might write that inside the tyre in chalk as well. You might write it on the outside of the tyre when you're back at the workshop, so you don't have to pull the tyre out of the rack to see. But those are the numbers which stay with the tyre for its life. And these ones stay with the tyre for just that event. So this set here was obviously a race set at some stage. It's now become a practice set for this event. So you can see you distinguish the two different markings, and you'll only refer to one at a time or something like that, but it's always cross-checks and references. And if you keep your database up to date, you can sort of work that out. So depending on what form of racing you're doing, you may not mix tyres up, so you just go set 1, set 2 and set 3, and that's how you run them in the races. But other events you may have to juggle your tyres around. You may have a mix of set 1 and set 2 on the car at the same time, or you may have a mixture of 4 different sets on the car at the same time. Just depends what gets thrown at you. So this is an example. We can see that they've labelled it left front, Eastern Creek test tyre. That's what's worked for this team, for their process. They may have more information just based on the barcode somewhere else. They may use barcodes. Some people use barcode scanners. We can see that on the tyre here. So that's just an example of it. So I think the best way to deal with this is we'll get into an example. So we've got, this is a practical one. It's a real life tyre planning scenario. So Kumo series, they only get 6 tyres for use in qualifying onwards. So the venue's Darwin. We looked at this earlier. That's your track map. I think we had sports sedans running there earlier in the weekend, I think. Qualifying's a 15-minute session. Race 1, you got 12 laps. Race 2, you got 12 laps, but they reverse the top 10. And race 3, we get combined points. So maybe get together with your buddy on your table and come out with how you'd use your tyres for qualifying. So let's say we've got tyres 1 to 6. As it works for this example, you've got 6 tyres to play with. I'd label them 1, 2, 3, 4, 5 and 6 for this weekend. So what would you guys do for qualifying? We'll give you sort of 2 or 3 minutes to have a think about how you'd go about juggling your tyres. You've got probably 15 minutes. Darwin, you probably get 2 qualifying runs in. So you get 2 cracks at it. What would you do with your tyres for those 2 runs is what we're going to look at. Okay guys, we've almost got a 2-run plan for qualifying, which tyres we're going to have on together. Okay guys, so what sort of layout would you guys run with? So obviously you've probably got to run 4 tyres straight up.
We figured we'd need 4 tyres to get started.
Yeah,
so
that's generally a good rule of thumb. Tick that box. I hope everyone got that far.
So we're off.
You're off.
For the second qualifying run, all we're planning on doing is swapping the 2 fronts across and doing the same with the rears.
Yep. Did anyone else have any other options they come up with that they do?
Just siding.
Just siding? Yeah. Would you put side the fronts and rears, or you just side the whole sets?
We said side the whole set because we don't know anything about the car.
That's cool. That's fair enough. Okay, and you need to gather information. There's only limited information here. You guys, anything?
I thought we'd scrub all the tyres, but leave the fronts on or the backs on depending on how they look after the track.
Again, you need to know information. So, Louis obviously got a heads up here, but that's roughly what I would have done. The reason being is that fronts are generally hard to get up on a supercar style car. You've got a lot of horsepower, you can spin the rear wheels, get them up, but the fronts are hard to get up. And traction's dominated. You overheat the surface of the rear tyre a lot with a lot of power. So front wheel drive would be a different scenario. But with 600 horsepower, they're spinning the rear tyres, they get overheated, so they lose performance quicker than the fronts, so you're going to degrade your rear tyre. So I'll be putting new rears on, so I'll put my 2 rears on, and I'd side the front. So obviously this left front doesn't cop much work. So you can go back to the right front, it's nice and preheated, ready to go. That right front that copped a fair bit of work, we'd put that over to the left front, so it's already preheated to get it ready for the left front, because that one's going to be hard to get ready. So you can see, obviously you need to know a bit more information about the car and the category and everything else, but you can see why you develop that thought process. And I think for Kumo, that's almost a strategy I'd use every week. Because you get 6 tyres, I'd almost use that one every week. The only problem is potentially you've got used tyres and how you balance that situation. So that's the rough start of how I'd go into qualifying. There's no right or wrong answers. Potentially you drive as a rookie, you just run the whole session out and give him some miles. Maybe you're coming inside the tyres halfway through because there's a red flag, something like that. But that's a rough guideline. No right or wrong answers. That's just some guidelines you can see, start to think outside the square. Now you had 2 sets, you could diagonal across them and put 3 tyres on at a time and all sorts of things. It gets complicated. So based on that, we've got 3 races to use our 6 tyres. Give you guys another sort of 3 or 4 minutes and come up with how you'd use your tyres for the race. Right, so what do you guys end up running?
Alright, so race 1.
Yep.
Front 2-1, so we just 2 and 1 at the front.
Yep.
And we ran 5 and 6 at the rear.
Yep.
Race 2, 4 and 3 at the front, 6 and 5 at the rear. And race 3, we ran 3 and 4 at the front, and we ran 1 and 2 at the rear.
Okay, cool. So you obviously had to reuse some tyres, move them around the car. It gets complicated. You have left front crossed out, right front written on it, then left front rear again. So it's been in 4 different locations. So that's important. We can see you've had to use that tyre in so many locations. How do you convey to the crew that tyre gets on the car in the right spot? So that's important. That's why we use the tyre numbers. You draw a map of the car, the crosshair, and you'll have like this, 1, 2, 3, 4, and they can just go, okay, for race 1, I need tyre number 6 here. Okay, that's in the right spot, and put it on. It's very important. You can see how easy it is to get that wrong. Communication's important. We covered that earlier. So this is what I would have done for the races. Just basically, depending on my default plan, and I've got it a bit tricky for you. So I'd start with my same set. I'd then move my left rear up. So that's a weak tyre, but it's in a weak spot on the car. I'd turn this one on the rim to try and use the opposite side of the tyre a bit better. Alright, so get a good right rear on as often as I can. Then basically do the same thing again. And the race 3 you end up with a bit of a mixed bag of tyres that you've done. So your right front is on its second stint, but it's turned on the rim, so that inside edge should be reasonably good. The left front, it's done 2 stints, but it's all as the front, so it's in not too bad condition. Your right rear is a good tyre. So you've got a good tyre on the right rear, which is a critical tyre for every race, so should have good performance there. The left rear having to compromise and reuse with it turned on the rim, but hopefully the opposite side, the way your cambers are set up. So in that scenario, they're short races. You could run maybe more camber to turn the tyre on earlier, and it means that you can turn it on the rim later and get the other side that hasn't been on the road. So things like that. An added complexity to that is, well, that's our plan before we get to the circuit. We've made this plan, we haven't even qualified yet, but that's roughly what we're going to do. We're going to give that to the tyre guy. But what happens if you qualify 25th? So that might change your plan. You might have to react to that. You might do something differently. So this is what I do in that scenario. You have to start on 4 tyres, so that doesn't change. But the best you could expect to probably get to is 12th to 15th. It's only a 15 lap race or 12 lap race, I can't remember exactly what I said. 12 lap race. You're not going to pass many cars in that scenario. Even if you were the pole sitter and you had a bad qualifying because you got run off the road or something, you're not going to get that far forwards. So even if you got to 12th, 10th is the race 1 winner for the reverse grid. So for my mind, you're not going to be able to pass the race 1 winner. He's going to be fast enough. So the 5 or 6 guys in front of you are all reasonably fast. You're not going to pass them. The guys behind you've already carved through because you're a faster car. You're out of position. So I'd almost reuse my tyres in race 2, cross them all up, reuse as many as I could, so that then I have the best tyres available for the last race. Still have a good right rear again, and then I could try and just basically, that left front, I'd just go off the wears. I'd dynamically do that. What's my best wear available? And the left rear, I'd actually have turned it twice. So I've turned it once when it went on the right front, and then turn it again and go back to the rear. So hopefully it's like even the tyre wear right out across it. So that gets tricky as well. So you can just...
I was going to say another thing as well is the temperature of the day. normally when it's hot, and I'm talking about track temps of 40 plus, you don't get the benefit of a new tyre. Like it's okay, but it's not as good as if it's a morning session. So if race 2 happens to be in the morning and race 3 is in the afternoon, maybe race 2 is better running good tyres. And if that guy, the 10th place race 1 winner, says, oh yeah, I'm going to run some old stuff because I've got to cut through traffic, you might get in. You know, so you've got to also think about the day temp. In Carrera Cup, whenever it was hot, it didn't matter which tyres you put on, it was shit.
They go over their thermal limit, and it doesn't matter.
Doesn't matter. Yeah.
So we'll go into, next thing we'll talk about is tyre pressure growth. So our tyre pressures, we all know that tyres expand as they get hotter, or the pressure goes up. The gas inside them expands as it gets hotter. So it's basically, we can treat this with simplified thermodynamics and ideal gas law. So the gas state is defined by several things. That's the pressure, temperature, and its volume. All right? So we're just going to treat this as a simplified concept, brush over a few bits and pieces, but that's the simplified thing is pressure, temperature, and volume. So when a gas gets heated, it wants to expand. There's more energy in it. It wants to expand to try and equalise its energy. Unfortunately, a tyre is limited volume. Tyres, we can almost a fixed volume. They do expand a little bit, but generally they're a limited volume. So as a result, the pressure has to increase. It's pretty straightforward. We've all experienced it. We've had cars. Tyres come in hot. The pressure's a lot higher. We're going to do a little example there, but unfortunately it's cold outside today. So what governs this is what's called the ideal gas law. Basic thermodynamics, bit of chemistry in there. So the way that works, PV equals nRT. Right, we'll run through that. So pressure is the P part. That's absolute pressure. Volume. So that's the volume of the tyre, or the gas that's inside the tyre. N is the amount of gas. Moles is a chemistry term. There's other ways. The R is the ideal gas constant. So that has different units depending on what units you use for all the other values. And T is the temperature, and that's absolute too. So that's relative to Kelvin of 0. So that's our gas law, and that sort of governs. We use this as a guideline. So we generally use nitrogen in a tyre. It's not quite an ideal gas, but it's pretty close, so we'll fudge it. Works for us, you know. And the important part, you know, the reason we use nitrogen is because it's cheaply available and it's generally dry. You can buy different grades of nitrogen which are dry. You can also buy dry air if you wanted to in those gas bottles, which is just moisture removed, but the cost of that's higher. And if you watch, so Michelin, I think at Le Mans, they don't even use gas bottles. They used to use special air dryers. So they use air in the tyres. They run through a special drying process just to remove the moisture, because the moisture is a state change. So when a liquid turns into a gas, it's a massive expansion, like tenfold. So we want to eliminate moisture inside the tyre. Careful mounting your tyres when a wet day, humid, make sure there's no water inside them, all those sorts of things. Any moisture in that carcass that turns to steam, because tyres operate around 100 degrees, is going to be a massive change in pressure. And we don't want that because it's inconsistent, hard to predict. How do we know how much moisture is in that tyre and how much it's going to affect our pressure? It's really hard. If we have an ideal gas, it's ideal, we can then predict it and map it much more easily. So how does the ideal gas law apply to tyres? So we've set our pressure. We did that this morning on this tyre, but once the pressure's set, the number of moles or the amount of gas that's inside the tyre is fixed. That doesn't change. The amount of actual molecules of gas is fixed. We've set the pressure, we put it in there. So effectively we take our equation and now we've got a constant. We've taken the V over the other side. So we've got a constant amount of gas and the R is a constant as well. It's like one of those mathematical constants for chemistry. So the R and the N become a constant. They don't change. So we've got a constant number. And we've got the volume of the tyre, the temperature of the tyre, and the pressure that's in there. But we know the tyre volume is almost constant. It does stretch a little bit, you know, tyres balloon, depends on the construction, all those things, but generally it's pretty constant. So we end up with the pressure is approximately equal to the constant times the temperature of the tyre. So the rule of thumb for a GT size tyre is roughly that a tyre will change about 1.1, 1.05 psi for every 10 degrees. Slightly different volumes of tyre, so the front and rears will change slightly differently, but that's a rough rule of thumb.
Is that nitrogen?
Any gas, any ideal
Oh, I guess
gas.
that's constant,
Yeah, so rough rule of thumb, just so you can do it off, just off the top of your head. So the way we'd actually determine that value is measure the cold pressure and carcass temperature. We did that this morning. Then we'd go and measure the hot pressure and the carcass temp. So we know that the pressure cold is a constant times the temperature temperature cold, and the pressure hot is a constant times the temperature hot. So we can rearrange that, and we can eliminate our constant. And now we've determined this ratio here of our cold pressure, cold temp, and our pressure hot, temperature hot should be equal to each other. So now we'll do it as an exercise. You guys we'll go through it together. So we set a tyre at 20 psi, 16 degrees, so a little bit colder than this morning, but something you might experience at Eastern Creek or Wakefield early in the morning. May even be colder than that. We go on a 10-lap run, so a reasonably long run. Tyres we'd hope would stabilise by then, may not, depends on the category, how hard you're pushing. Let's just say that's our normal sort of rate, 3/4 race distance. You'd like your temperatures and pressures to stabilise by then. And we've gone to 32 psi hot. So what's our hot air temp going to be? We don't have a tyre pressure sensor, but we can maybe estimate that. So what we'll do, the first thing we need to remember is that everything needs to be in absolute units and in base units. So it's pascals, and it also needs to be relative to 0 psi. So a tyre pressure gauge, so when the tyre has got no air in it, it's actually at 14.7 or 14.5, atmosphere. So remember, you've got to add that to your pressure, 14.5, and also your temperature needs to add 273 to get it to Kelvin, relative to Kelvin 0.
Which is space.
Hmm?
Space. It's Kelvin 0. It's
Yeah.
vacuum.
Vacuum. Oh, yeah.
So 0 degrees on planet Earth is still 273 degrees in space. Kelvin.
That's what I had for my equation before, didn't I? And you guys have got that rearranged. So it should be
Please, pressure on temperature.
Or you could
Pressure on cold.
could be the other way around.
Temperature.
Still works.
So it's PK, the pressure Kelvin, PC.
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 I got that right?
T equals RT, PV equals RT, so P1 over T1 equals P2 over T2. So P hot, yep, it is, because P hot's going to be more than P cold.
Alright, so our T cold was 16 plus 273, 0.15. So what does that give us, people? Alright, I think you've got some conversions there, have we, for the gas? No.
There's a conversion.
Oh, there's a conversion
sheet
sheet.
at the start of the
Yeah, conversion sheet at the start of your handbook or the course book?
course book.
Yeah, it's a conversion sheet to get your pressure hot, which will be 32, we said, plus 14.5. So then we've got 20 plus.
There's the whole thing's PSI.
You can do it in PSI as long as it's absolute. But just do it in pascals.
1013.
Yeah.
Atmosphere.
Yeah.
What are you going to use?
That's 1 atmosphere. 1 bar is 100
Okay, so it's
kilopascals.
20 pound.
did it say?
Pressure cold.
Yeah, no, you got that wrong.
You got that
That's
101
20 psi.
20 psi?
Is more than 1 atmosphere.
Yeah.
Yeah, you still.
1 atmosphere is 14.7 psi.
So you have to divide by 14.7.
So we've gone 20 pounds.
You want to do it that way?
Yeah, okay, 20, divided by
You want to
40.
do it in bar.
14.3.
200 atmospheres.
So we're using for atmosphere. Yep.
I always do it in pascals. That way, it's base units.
Yeah, that's
Yep.
Okay, 41.
So PSI to pascals is, I forget,
Pascal.
6, 8, 9, 4.
Yeah.
Should get
Yeah.
around about
Pressure hot is
238, 240 kilopascal.
So we got 32 by 6.894.
Pressure hot. 226. 65. Question is what?
use the other pen.
What temperature from that pressure, right?
The temperature we want.
So basically we get our
Supposed to be
absolute pressures.
pressure.
So 32 plus 14.5 times your 6.894 to get it to Pascal. Do the same for your pressure cold. 20 plus 14.5 by 6.894. Divide those two, multiply them by your cold temperature, your TC. So we just rearrange that formula we saw before. It's 289 I think we said. Minus that by 273 to get it back to degrees C, and we should get our hot temperature. Anyone got a magic number yet?
What was the 2.89 again?
289. That's the T cold.
Oh, that plus, okay,
That's a multiply there.
yeah.
Sometimes I say, how can you, and I look at it and go, just, it's done, right, you know?
Experience.
That's right.
You know what you're expecting.
Sometimes I don't even do it exactly that, I just go, Funny thing was, when we were doing the test the other day, when we swapped the tyres left to right, and we had to do a swap on the pressures, and so I was just watching the telemetry, and I said to Lee, so that the tyres settled, oh, we don't have time, so I went, okay. 0.3, and he went, oh, how come it's not 0.5? 0.3. And it worked out, right?
Yeah.
I took 0.3 out of one, put 0.3 in the other. Because you just run through this number in your head very
Yeah.
quickly. It's a very powerful tool. Very powerful tool. You look so smart when you do use this and you get your pressures right regularly. Like it takes a little bit of time.
A lot of so-called professionals don't.
Yeah, like some people just do pluses and minuses. Oh yeah, I was 6 pound, or I was 3 pound too high, and I'll do half that difference cold, and you know, make the adjustments. But if you do it this way and you do the maths, you 90% accuracy.
So 32 plus 14.5 times 6894. 20 plus 14.5 times 6894, I think is a conversion.
Is that 0.69, sorry?
Is it 6.89 or 0.68?
6.894.
We're close.
Got something like that, that's right.
What do you got?
Yeah.
115.95.
Sounds very, very close to me.
Oh, really?
Yeah.
I got 6-1, but I didn't
You
get
got decimal place wrong.
Are you in Kelvin?
I've gone to Pascals. Pascals.
What's that number there? 146.
That's 141 kilopascal.
So if you had any humidity in the tyre,
It's just boiled.
what happens to it? It comes at 16 degrees. And you know what happens with a
Well, wouldn't see when it puts under pressure.
well, it may no, it's still with 30 pounds of pressure, 2 bar, it maybe gets 120 before it gets into proper steam.
I've seen tyre air temperatures over 150.
Sorry? Air
I've s-
pressures.
Air temperatures inside the tyre of more than 150.
Oh, wow. Okay.
Yeah, but do we need to? So ask me
I guess the rim would just be radiating so much heat into it.
That's probably
You put it back to Celsius because then it's human.
Yeah. Okay.
Oh, it's hot today, geez, 298 Kelvin.
Yeah.
That's typical. That's a nerd joke.
We're pretty close.
5, 6, 7.
I probably use more decimal points, or you use more decimal points.
I think I rounded.
Keeping it very soft, just not make it absolute.
Yeah.
14's
You can do that.
No,
So I've got this top line here for the P hot. That should be, is that 320?
Mm-hmm.
321.
Yeah, so
that's the decimals.
roughly
What have you done that by? 6.894.
No, I know what's wrong.
something like that.
Yeah, didn't have atmosphere to that.
20.
894. But then I'll round it because
No,
it
that's
gives me
plus 14.7.
8 decimal places on that.
That's not absolute. That's above air pressure.
And I got 237 for this one, 0.8. Is that what everyone else got?
Air pressure.
yeah, I'll see where he's
For the
Yep.
pressure cold in base units.
I got 237.8.
Yeah. So
Round up Mitch over here.
obviously this is going to be plus 273. Whatever you get your answer in Kelvin, you're going to minus that to get it back.
You'd be surprised.
Right.
That's
He's speaking from experience.
Yeah. So
every decimal is important.
there's a difference between accuracy and precision, is the way the physicists will describe it. Also remembering we're assuming our tyre has got a constant volume, which you know that a tyre will slightly stretch, it'll change a little bit. So that's one thing and probably a tip. If you go and do a hot bleed, so say you came in at 36 and bled them down to 32, do it again. I guarantee you go around and check your tyres 30 seconds later and they'll have changed. Go up half a pound as the carcass relaxes. So you've got to be mindful of that sort of thing. But this is an approximation, you know. So we go, roughly we know our hot temp is going to be somewhere around 116 degrees, give or take, you know, gets us in the ballpark. Is everyone sort of okay with that one? So the next question is, we're going to warms up the day during the day. We get to 25 degrees C, so it's gone up 9 degrees. Question is, so now we want to set another set of tyres so they get to 32 psi hot. Right, so we've got a second set of tyres going on, they haven't been set yet, we've just gone and got them mounted. Or maybe it's our Kumo one, which we've had to go get dismounted and turned on the rim to put back on. We need to reset it, ready to go. So what's our new cold pressure at 25 degrees C?
There's another exercise.
Yeah, same thing, except it's not, it goes to 25. And the other thing is, you know that number is constant. Now you want to work out what that 32 is hot. You want to work out what the cold pressure is.
Alright, so let's see.
So instead of saying is if we change it to cold,
Pressure hot.
Pressure
What do we
cold,
know?
we don't know.
What are we going at the moment?
32 hot?
32 hot. PSI.
Yeah. You know temperature hot? It's 178.
274.
104, yes. Same diet, just
At
different
25
diet.
degrees.
Temperature hot.
178. Temperature cold. Cold temperature.
Is that it?
289.
Yeah, the new temperature cold
Yeah, sorry. Yeah.
is 25 degrees, so it's warmed up.
Yeah. We want to know the cold pressure.
And we want to,
Start off with-
what pressure should we start with to hit our target of 32? Because if we started with 20, the tyre is already hotter.
I know that
Yeah.
number.
Okay.
You could go both ways, couldn't you? You could attack it from both sides.
So cold pressure.
Try that.
I'm just going to attack it from both sides.
No, hang on.
Pressure hot is
Hang
going to
on.
be.
Plus.
No,
Plus and
as in
plus.
now I'll put it under C. Rightio, so pressure hot. Just do absolute.
Yeah, it's
It's bar and atmosphere, small difference there.
Plus
Take your pick, whatever you're using as base units.
394. Right.
What's the 39?
The 117.
Yeah, yeah.
I tend to use bar.
Yeah.
By 14.7.
14.5 I think is bar one. I use 14.5, I can't remember.
Some of the numbers on there, I did
So in our equation that we started off with, this top one here, right, so we rearranged it. We know our pressure hot that we want, because we're determining we want that. We know our temperature hot, because we just worked out what it was off a good practice run we had earlier in the day, or a race run, whatever that was. And we know what the cold temperature is, because we know what the measure of the temperature of the day is at the moment.
Minus.
So if we just convert these to our absolutes again, perform the equation, we should be able to calculate our pressure, new pressure cold we need to set our tyre at.
This is absolute.
Absolute.
Therefore, pressure cold is
894.
What'd you get? 21.
21. 07. Oh, no, 8, same. 21.
Oh, that's what I did wrong.
Well, my TC, previously I understand that was 16 degrees C, but now they've changed my TC is now 25, is that right?
No.
It's
Yes.
Yeah.
You can go both
Oh,
ways.
sorry, yes.
That's what I'm doing. I'm going both
Yeah,
ways.
yeah, it is actually.
I'll tell you in a second if you can do that.
That's the 117 there.
Yes.
What did you take as your reference, the hot conditions or the cold conditions? So you can jump from 16 degrees to 25 degrees, or you can jump back from 32 psi to 20 psi. Or no, you can jump from 116 back to 25, or you can go from 16 to 25.
Give us another temperature.
Because it's a straight line. So you can go both ways.
Yes. It's just the ratio, isn't it?
Yeah.
So we get an answer there? Yeah.
22.8.
Yeah, almost.
21.1 is roughly what I got, rounding, taking into account a few approximations. Right, so the other alternative way to look at that is without their estimated hot temp. If you know you start pressure, you could treat this as your new hot temp, and what pressure would that tyre expand to as well, if you know the ratio with temperature. So there's a couple of ways of approaching it. But the important thing is to grasp the concept that obviously tyre pressure is a function of temperature, and obviously as the temperature of the day changes, a base pressure will shift up and down that curve. So V8 Supercar, the prime example, reusing tyres. The tyre will come off the car at 100 and you've got a minimum tyre pressure rule, but you want to get below that. So you can preheat the tyre and then bleed more air to get it below the temperature, and you'll have situations where you'll have a temperature cooling curve and you're trying to make sure you hit the right spot on that curve as well. So is everyone across this concept of this, using this ratio to be able to set new pressures when the temperature of the day changes? So I think that is quite important takeaway from this whole exercise, is being able to use Excel spreadsheet.
One quick question on that calculation there, where we done the temperature height, how come we use the 16 degrees?
Which one? 116? Oh, that's just from, it was 115.9 or something.
That was that inside the carcass,
The
the
previous.
air
Yeah.
temp
Yeah,
inside
yeah,
the
yeah. Yep, okay.
Yeah. So when it was at 32, it was at 116,
Yeah.
assuming. You might have data from that, you could have measured it when it came in or something.
Sorry, yeah.
Another way to do it.
You do need to do a test first, don't you?
That's what I meant to say.
You need to know some.
Yeah,
I knew
you
that.
do need to do some testing first, and then from there you can crunch it out.
Yeah.
Because that's what I wanted to figure out.
What do we get?
Yeah.
We get an answer?
21.1.
Alright.
So it's obviously, it's got hotter, the pressure would increase. We've got, our number is higher than what we started with when it was cold. It's roughly, what does that work out for 10 degrees? Roughly 1.1, a little bit less, maybe a little bit more.
What did you start with? 20 psi?
Right. At 16, it's gone up 9 degrees and gone up 1.1. So
So 1.1 divided by 9 degrees. 0.12.
so for
So 12 per 10.
Yeah.
12 per 12.
1.2.
1.2 per 10.
So I said for a GT tyre before, about 1.05, somewhere 1.1. For this tyre, on this car, it would be 1.2 for 10 degrees. So you just go, oh, it's 10 degrees warmer now. I know that the pressure's going to go up about 1.2 psi. Quick rule of thumb, quick check. So the next thing with tyres is